welcome to the last session of today. So I'm in between you and drinks, which is always a great place to be. Please welcome Ruben, my more technical colleague, who will take over later on. But today I would like to talk about what we're going to do as soon as we have a working OpenStack installation. Maybe a quick introduction on who we are. So we both work for Kangaroot, which is a Belgian open source service provider. We've been in business for over 17 years, and over those 17 years we've only been busy with open source. We try to be, which isn't easy in today's world, but we try to be as independent as possible. So we're not tied to any vendors. We have our preferences, of course, and they change according to the customer's environment. But we try to propose a good solution based on what the customer wants to do, what they already have, and so on and so forth. We take time to test new stuff so we can present it to our customers as soon as it's ready for production. And we start from advice, design, implementation, support. That's the stuff we do. If you have a quick look, and you'll have the slides later on, we do all kinds of open source technologies. We have a number of support services and consulting practices that we do. But enough of the marketing talk. What we would like to talk about is what people have been trying to achieve with OpenStack. Why do organizations look at OpenStack, and why do they start the implementations, and so on and so forth? I think this list is quite clear. They want public cloud features, but in an on-premise or in a more controlled environment. They want APIs to talk to. Just hand it over to the developers and have them do their own thing, talking to these different APIs. The final goal for a lot of people is to have faster and better releases. Yeah? Developing software, getting it out there more quickly, and better, because a lot of people are afraid to change their platforms because they don't know if it's going to work after a change. If you have a platform like this where you can automate a lot of things, deploying and releasing new versions becomes easy and predictable. Scaling up and down automatically based on loads, based on what your teams are doing, stuff like that. That's why people are choosing for OpenStack. And of course, the fact that it's open source or can be self-hosted or is vendor independent are all things on top. But basically, it's all about the applications. So finally, people just want to build new applications and get them out there. But if you want to get them out there, you need a good platform underneath. Now, if we look back at, I think we've been involved in OpenStack stuff for around 4 or 5 years, something like that. We've seen a lot of interest from our customers. But at the same time, and if we look at this Google Trends here, something else came up as well. So people were looking at OpenStack, virtualization technologies, and so on and so forth. But during those, if you look back, 2013, all the way to this year, a technology called Docker, or containers in more general terms, started to become more popular and more popular and more popular. And it even surpassed the interest in OpenStack. Because of course you have a lot of developers looking into Docker containers and so on. It became clear that containers became a big part of what OpenStack can do. Yeah? Even more so because the original idea behind OpenStack was already to chop things up into different kinds of services that you can easily have them scale and so on and so forth. So the container thing and OpenStack came together. So basically, what happened was 2 actions. People started to look at containers to deploy OpenStack more easily. And of course, people started looking at containers to deploy their applications on top of OpenStack. Those two ways came together, and there's a number of possibilities to be able to deploy OpenStack in and on top of your infrastructure. I think I'm going to hand over to Ruben now, easily.
Okay, so if we talk about containers, we want things to be upgradable. We want to be able to manage our infrastructure. We want containers to be stateless. Why do we want containers to run OpenStack? Because OpenStack is very complex software. It is built out of dozens of projects. It is built out of microservices. All of those should not depend on each other. So you want to be able to upgrade parts of that infrastructure without impacting the rest of the infrastructure. That is one big reason why we want to use containers to run OpenStack. It's extremely mission-critical software. You don't want your virtualization platform, in this case OpenStack, going down because you are upgrading your software. Everything needs to keep running. And of course, you can have development, acceptation environments where you test your upgrades. But we all know production can still cause some extra issues on top. So containers are built to handle failure, or at least the applications that you run in containers should be built to handle failure. OpenStack software is made to handle failure, is made to run high available. So they are perfect for running inside containers. You have a rather short development cycle compared to legacy software. You have every 6 months where a new version of OpenStack is available. So you'll have to go through this upgrade procedure a lot of times. So you want it to be as smooth as possible. So that is one other reason why you want containers to run OpenStack. How do we do that? There's a few different projects that allow you to deploy OpenStack using containers built in. Primarily, there is the OpenStack Ansible, originally developed by Rackspace. Nowadays, it's upstream. It's part of the main, or one of the main ways to deploy OpenStack, mainly focused at deploying on top of Ubuntu. You have as well Cola, Fuel, all other projects that support deploying OpenStack on top of containers. So the technology is out there, not everyone does it, but if you can, if you're working with a new OpenStack deployment, definitely consider using containers to deploy it. In the future, everyone that we know, that we work with, is looking into containers. But it's not that easy to switch from non-containerized environments to containerized. So if you're still making your decision, focus on already containerized platforms. Secondly, not just running OpenStack on containers, also running containers on OpenStack. You want your applications to run in containers. You want to deploy them on top of OpenStack. We see two major options. One of them is where you actually have the container management platform, which is, for instance, Rancher, OpenShift. Those platforms manage the containers for you. You deploy this platform on top of OpenStack, and you deploy your containers, your applications, on top of this platform. OpenStack will provide the virtual machine resources. Just using Nova, you deploy machines, you deploy or you install the container management platform on top of OpenStack. All of the interfaces, APIs, everything is provided by the container management platform. This is a perfectly valid approach. it all depends where you want to have the responsibilities, where you want to have connections between your virtualization platform or connections between your virtualization platform and your container platform. Second option, OpenStack service, which is actually the one that deploys your container orchestration engine. It's mostly similar in terms of approach, but the integration is typically a lot better. This approach, because you see it at the last bullet, Magnum. Magnum is a project in OpenStack. It's available since Mitaka, I believe, that allows you to actually integrate your container management with OpenStack. What it does is it actually uses heat to deploy your container management platform, as well as connect to Cinder and Keystone, Cinder for storage, Keystone for authentication. So the users that log into your virtualization platform can also log into your container platform. It offers containers as a service. This means that a user on your OpenStack platform can easily deploy their own container management platform. It means it's not a shared platform. Every management platform is deployed per tenant. So it's not like an OpenStack platform where everyone uses the same infrastructure. Actually, you dedicate resources, or your user dedicates its own resources to running the container platform. As you can see, separated per tenant by Nova, so every tenant has their own resources. What does it look like when we deploy in this way? This is the first option, where you actually deploy the container management platform yourself on top of OpenStack. So this diagram partly illustrates what I explained just now. You have your OpenStack platform. You have your Horizon APIs or interfaces, depending how you connect to it. You have the Nova API, Cinder API. Horizon is the web interface. Nova manages your virtual machine resources. Cinder manages your storage resources. The OpenStack user in the top left actually connects to the Horizon API or the interface and starts the deploy of virtual machine resources. One thing that we list there is Terraform. For those of you unfamiliar, Terraform is a tool that allows you to describe virtual resources in code. So it allows you to store your definition of what virtual machines you need into files, which can then be committed into source revision systems and so on. Very useful to work across clouds, because you can use Terraform to connect to AWS, to Azure, to OpenStack, whatever you like, with minor changes to the code. First step, you deploy your infrastructure. You create storage to deploy your container platform on top of. Once you have that, you install Red Hat OpenShift, for instance, or Rancher, or any other container management platform that you may prefer. These container management platforms, as we call them, use internally either Kubernetes, Swarm, Mesos, any other alternative options that are supported. OpenShift typically depends on Kubernetes. Rancher supports all three of these listed here, but you don't know what the future may bring. Once you have your container management platform, this one will actually deploy the infrastructure to run your containers, which can be Docker, Rocket, Creo, whatever container technology that you may want to use, typically Docker. Main thing here to look or to notice is that we have an OpenStack user, which is connecting to the OpenStack platform, but we also have an OpenShift user. This may be the same user, but it doesn't have to be the same user. There are different databases. They will connect to different platforms. Second approach, Magnum. this is the one that integrates with OpenStack more. Looks mostly similar, but here you have actually one single user who deploys the container orchestration engine. So you no longer need an OpenShift or a Rancher. You actually do that through Horizon. You talk to the Magnum API. Magnum talks to Heat. Heat is the component in OpenStack that allows you to describe stacks of virtual machines. So you can deploy many machines through one single API call. Magnum builds Heat templates for you to define these container orchestration engines. So with one simple call that defines a set of parameters, you deploy your complete container orchestration engine. The container orchestration engine also communicates with Cinder to provide persistent storage for your Docker containers. So you have integration on that level as well. Other than that, the principle is the same as the last slide. Every user has their own resources. Every user has their dedicated container orchestration engine and runs their containers that way. Okay.
So to round up, we've prepared a bit of a customer case where we've done a number of these things. The Port of Antwerp, which is, I think, quite familiar for a lot of people in the room. It's one of the largest ports in Europe, I think together with Rotterdam and Hamburg. Yeah.
Second day.
one of the largest. So I'm staying neutral here. We started talking with them, I think, end of 14. They had an existing KVM setup, but it became too hard to manage. There was a lot of manual scripts involved and all that kind of stuff. I think a few of you in the room know what we're talking about. But one of the main things when we started talking to them about OpenStack was that they had a complete multi-site requirement. So they have 3 data centers. One is a small one being used for quorum and that kind of stuff. But they wanted to be able to run it across 2 of their data centers. So that was, I'm not going to say a big of a challenge, but it was something that was one of the first ones that started talking to us about a multi-site setup for OpenStack. What they wanted to use the OpenStack platform for was new cloud-native applications, which is a perfect fit. They had a lot of hosted applications, websites, that kind of stuff, dispersed across a number of vendors and partners all over the country. They wanted to get all of those back in-house on their own platform, being able to manage that themselves and so on and so forth. And a big one was to be able to provide sandboxes to all of their developers, that they just could have a self-service portal and so on and so forth. The cool thing about it is that we provide this service to them in some sort of an OpenStack as a service model, where we managed to get them inside a HPE program where they pay for their subscriptions and support per month. So when they grow, they pay more. When they decrease, they pay less. And part of the whole deal is that we manage it for them. So we're on site a couple of times a month. If they have issues, we do housekeeping and so on and so forth. Ruben has prepared a slide of what we've done there, and I'm going to hand over back to him.
Okay, so this is the platform that we set up for Port of Antwerp. Looks very similar to the previous slides, just has some additional details on how we did the actual implementation there and on how they are using it. So, infrastructure admins. These are the people who are actually logging into OpenStack and deploying new infrastructure. They are big fans of Terraform because they can describe everything in code, which means that they can throw away their whole stack and redeploy it in a matter of minutes. Terraform talks to Horizon API. There's no support yet for Magnum. Magnum is not that known yet, which is one of the reasons why we opted for this design and not for the integrated one. Terraform talks to Horizon. Horizon talks to Nova, to Cinder, creates the necessary infrastructure. All of that is done automated. They will then deploy the infrastructure which is needed to run OpenShift Origin. They are big fans of open source as well, so they are going for the open source version of OpenShift. We are using HP Helion as OpenStack. No Red Hat there, so there's also no reason to go for the Red Hat OpenShift. We, as Kangaroot, use Ansible primarily to deploy everything. We are big fans of Ansible for the same reason that Port of Antwerp is fans of Terraform. We can describe everything in files and automate everything. We use Ansible to deploy the OpenStack. This is actually part of HP Helion, the distribution. There is a whole Ansible installation included in this. It's a rather complicated setup, but it is very versatile, and it actually allows us to deploy this multi-site OpenStack, which is one of the major requirements for the Port of Antwerp. We use Ceph as storage there. Very typical, recommended in an OpenStack environment. Also open source, so one of the choices that Port of Antwerp had made in advance, and supported by HP Helion as well. So it is the same Ansible code that deploys the OpenStack platform, which actually deploys the Ceph nodes. We deploy OpenShift Origin. The Terraform actually deploys heat templates that Port of Antwerp developed themselves to deploy the OpenShift nodes. OpenShift uses Kubernetes. Kubernetes has Docker containers underneath, which is running the different applications that they are using. The DevOps users, which are not the same as the infrastructure admins, which is the case in many bigger companies, they are the ones that use OpenShift Origin. They don't need access to the OpenStack environment. They don't have access to the OpenStack environment. All they do is get access to OpenShift. From there, they click, get a new container, deploy their software. What we do on top of that is we have ELK, Elasticsearch, centralized logging. We use the logging to centralize all the logs from the OpenStack platform, all the logs from Ceph, just as well all the logs from their applications, all the logs from their firewalls. All of that is pushed to the ELK stack, which is actually running on top of OpenStack again. This is a temporary situation. We may actually go for deploying physical nodes or deploying another virtualization cluster next to it once they've adequately tested the ELK stack and are happy with the setup, but performance-wise, it's not ideal. And again, we use Ansible, also the Ansible that is provided by HP in the Helion stack to deploy the ALK. But they actually have the XPack, so the paid setup for ELK, so there is some additional customization required. And that's the setup that Port of Antwerp uses and has been using for over a year now to deploy or develop all their new applications. It's primarily a development platform at this point, but we imagine, and so do they, that soon enough when those applications start to go into production, that the OpenStack will get a second brother similar to this setup, which will hold all their production software. That's it. Anyone have questions? No? Okay, then we won't let you wait any longer for the drinks. Bye.